The adapter design pattern is a structural design pattern that allows objects with incompatible interfaces to work together. The adapter pattern wraps an existing class with a new interface so that it matches the client's expected interface. This pattern is particularly useful when integrating legacy code with new code or when a class does not have the desired interface. I'm Balaji Chandrasekharan. Please like, share my video, and subscribe my channel. The following are the key concepts of the adapter pattern. Adaptee is the existing class with an interface that is not compatible with what the client expects. Suppose you have a logging system in your application, and you want to integrate two different types of loggers, file logger and database logger. Each logger has its own unique interface that does not conform to the standard logging interface used in your application. You can use the adapter pattern to create a consistent interface for logging messages. The file logger and database logger classes are the existing logging classes with different interfaces that we want to adapt. File logger is having a functionality as write to file. Database logger is having a functionality as write to database. Target interface is the interface that the client expects. Logger class is a target interface that defines a standard method, log, for logging messages. This is the interface that the client interacts with. Adapter is the class that implements the target interface and wraps the adaptee to translate the requests from the client to the adaptee. File logger adapter and database logger adapter classes implement the logger interface and internally use an instance of the corresponding adaptee to perform the actual logging. The adapter translates the call from log into a call to the appropriate method on the adaptee, write to file or write to database. The client is the class that expects to interact with an object that implements a specific interface. The client code is unaware of the specific logging implementation. It interacts with logger objects, and the adapters handle the specifics of invoking the correct logging methods on the adaptee objects. The following are the benefits of the adapter pattern. Reusability, allows reuse of existing classes even if they don't have the required interface. Separation of concerns, the adapter separates the client code from the adaptee code, making both easier to maintain. Flexibility, new adapters can be created for different adaptees without changing the client code. Some of the use cases of the adapter pattern are: integration with legacy systems, when integrating with legacy systems that do not follow the current application's interface requirements. Third-party libraries, when using third-party libraries that have different interfaces from what your application expects. Multiple interface requirements, when a class needs to use multiple external systems with different interfaces. The adapter pattern is a powerful design pattern that helps integrate incompatible interfaces, making it easier to work with legacy systems, third-party libraries, and different interfaces. By using an adapter, you can ensure that your code remains clean, maintainable, and flexible. We have reached the conclusion of this session and look forward to seeing you in our next one. We hope you have enjoyed the video. Don't forget to like, share, and subscribe. Thank you for tuning in.